Video will go over an example of an interest problem. This is the fourth type of problem that we've seen in section 1.2. Now you may remember the formula interest equals principal times rate times time, where principal is our beginning amount, rate is our interest rate as a decimal, and time is in years. We will be making use of this formula. Here's an example of an artist who sold a painting for $410,000. So she needs to invest some of the money, but she doesn't want to invest it all in one place. She's going to invest some of the money for 6 months and the rest of the money for 1 year. Now, Treasury bonds are available for 6 months at 4.65%, and they're also available for 1 year at 4.91%. After talking to a broker, he tells her that the two investments should earn $14,961 in interest. So in order for her to earn that much money, how much should be invested at each rate? So here's what's going on. We've got some of our money that's invested at a different interest amount than the rest of our money. But when we add the two interests together, we get a total amount of interest. Our interest pile is a little bigger. I mentioned earlier, this question is going to make use of our interest equals principal times rate times time. And a good way to organize our information is by using a chart that is based off of that formula. So the formula itself is I equals P times R times T. We're going to rearrange that. Instead of the I being in the far left column, our interest, is going to be in the far right column. And I'm going to make it say rate times principal times time, because having the rate first, makes it easier for me to identify which pile of money I'm working with. So we've got these two interest rates. One is at 4.65%, and notice I'm writing that as a decimal. The other one is at 4.91%, also written as a decimal. And our principals, the amount that we start with, we don't really know how much money we start with. So I'm going to use X for one of my principals, and that means the remaining amount of money, which is all of it, 410,000, minus what I've already used. That's how I'm going to describe the other principal. Now, remember I said earlier the time needs to be in years. So the 6 months is 6/12 of a year, so 0.5, and the other one's for 1 year. Now, interest is going to be described algebraically. Principal times rate times time. So we multiply across. And by taking 0.0465 times 0.5, we get this really hideously long decimal. Do not round this decimal. We're going to do the same thing for the second amount of interest, rate times principal times time. And we end up getting 20,131 minus 0.0491x. Now remember, the first picture we had was the two piles of interest were going to be put together to equal the total interest. So we almost have our equation now. We're going to take this interest amount number 1, add it to interest amount number 2, and set it equal to the total amount of interest. And so here's what this equation looks like. We solve this, and we end up getting X equals 200,000. If we go back to the chart, we see that X represented the amount of money, the principal, that we invested at 4.65%. Well, if we invested $200,000 at 4.65%, then we can easily figure out how much was invested at 4.91%, which is what we were asked to find. So 200,000 at 4.65% and 210,000 at 4.91%.